Download this code from codegive.com, link in the description below. OK, let's dive deep into Java's executor service shutdown and await termination methods, with detailed explanations, code examples, and best practices. These methods are crucial for managing the graceful termination of thread pools in your applications, preventing resource leaks, and ensuring proper cleanup. Understanding the need for controlled shutdown. When you're using executor service to manage threads, typically a thread pool, you can't simply let the application exit without properly shutting down the executor. Here's why. Non-daemon threads. The threads in your executor, by default, are non-daemon threads. This means the Java Virtual Machine, JVM, will not exit until all non-daemon threads have completed their execution. If the threads in your thread pool are still running when the main method finishes, the JVM will wait indefinitely for them to finish. Resource leaks. Threads might be holding onto resources like files, database connections, or network sockets. A forced, ungraceful exit could lead to these resources remaining open or in an inconsistent state, causing issues later. Data corruption. If threads are in the middle of writing data or performing critical operations when the application is terminated abruptly, data can be corrupted or lost. Clean exit. A proper shutdown allows your application to clean up any temporary files, release resources, and signal other parts of the system that it's finished, ensuring a more stable and predictable exit. 2. The executor service interface and implementations. Let's briefly recap the executor service interface. It's part of the java.utility concurrent package and provides a framework for executing tasks asynchronously. Common implementations include thread pool executor, the most configurable implementation, allowing you to fine-tune thread pool parameters like core pool size, maximum pool size, keep alive time, and work queue. Fixed thread pool, creates a thread pool with a fixed number of threads. If all threads are busy, new tasks are queued. Cached thread pool, creates a thread pool that reuses previously constructed threads when they are available. If no existing thread is available, a new thread is created and added to the pool. Threads that have not been used for a certain amount of time are terminated and removed from the pool. Scheduled thread pool executor, an executor service that can schedule tasks to run after a delay or periodically. Fork join pool, designed for parallel tasks that can be broken down into smaller subtasks, divide and conquer. 3. The shutdown method. The shutdown method initiates an orderly shutdown of the executor service. Here's what it does. 1. Stops accepting new tasks. The executor service will no longer accept new tasks submitted via execute, submit, or invoke all. Any attempt to submit a new task after shutdown has been called will result in a rejected execution exception. 2. Allows existing tasks to complete. The shutdown method doesn't interrupt or cancel any tasks that are already running or queued in the work queue. These tasks are allowed to complete normally. 3. No immediate termination. Shutdown doesn't force the threads in the pool to stop immediately. It signals that the executor is ready to be shut down once all pending tasks are finished. Code example. Explanation. We create a fixed thread pool with 3 threads. We submit 5 tasks that each sleep for 2 seconds to simulate work. We call executor.shutdown. This signals that the executor should stop accepting new tasks. The main method continues to execute without waiting for the executor to finish. The threads in the pool will complete their tasks, and then the threads will terminate. If you try to submit a new task after calling shutdown, you'll get a rejected execution exception. Important notes asterisk no guarantee of immediate exit asterisk calling shutdown doesn't guarantee that your application will exit immediately after the main method finishes. The threads in the pool are still running and need to complete their work. This is where await termination comes in. Asterisk shutdown versus shutdown now. Asterisk will discuss shutdown now later. It attempts to stop all actively executing tasks and cancels queued tasks, but this can lead to data corruption or incomplete operations if not used carefully. 4. The await termination method. The await termination method allows you to block the current thread, typically the main thread, and wait for the executor service to complete its shutdown process. It provides a mechanism to wait for all running and queued tasks to finish or until a specified timeout occurs. Method signature asterisk timeout, the maximum time to wait for the executor to terminate. Unit, the time unit of the timeout argument, example time unit .seconds, time unit .milliseconds. Return value true if the executor terminated, all tasks completed, within the timeout period, false if the timeout elapsed before termination. Throws interrupted exception if the current thread is interrupted while waiting. How it works 1. Await termination, blocks the calling thread until one of the following conditions is met. All tasks have completed execution, including those submitted before shutdown. The specified timeout period has elapsed. The current thread is interrupted. 2. After one of these conditions is met, await termination returns. Code example, with await termination. Explanation This example is similar to the previous one, but we now call executor.await termination, 5, time unit .seconds, after executor.shutdown. This line blocks the main thread and waits for the executor to terminate for a maximum of 5 seconds. If the executor terminates within 5 seconds, all tasks complete, await termination returns true, and the program continues to the all tasks finished message. If the timeout elapses before the executor terminates, await termination returns false, and we print an error message. The interrupted exception is handled to avoid unexpected program termination. V. Using shutdown now, handle with care. The shutdown now method attempts to stop all actively executing tasks immediately and cancels any tasks that are waiting in the work queue. Key differences from shutdown, immediate stop shutdown now, tries to halt currently running tasks, typically by calling thread.interrupt, on the threads executing those tasks. Cancellation shutdown now, prevents any queued tasks from starting. Return value it returns a list runnable containing the tasks that were awaiting execution, queued but not started. Code example, with shutdown now. Important considerations when using shutdown now, data corruption risk interrupting a task in the middle of an operation can lead to data corruption. If a task is writing to a file, updating a database, or performing a critical operation, interrupting it might leave the data in an inconsistent state. Resource leaks interrupting a task might prevent it from releasing resources, example closing files, releasing database connections. Task responsibility tasks must be designed to handle interruption gracefully. They should check the interrupted status, thread.current thread, is interrupted, and clean up resources properly in the catch block of interrupted exception. Use with caution shutdown now, should be used only when it's absolutely necessary to terminate the executor immediately, and you understand the risks involved. A more graceful shutdown is usually preferable. When to use shutdown now, asterisk. Asterisk application is terminating unrecoverably asterisk if your application is encountering a critical error and needs to exit immediately, shutdown now might be the only option. Asterisk long-running or stalled tasks asterisk if you have tasks that are taking an excessively long time to complete or have stalled due to a bug, shutdown now can be used to stop them. However, consider the data integrity implications carefully. Asterisk emergency situation asterisk in emergency situations where you need to quickly stop the executor, shutdown now can be used, but again, understand the potential consequences. 6. Best practices for shutting down executor service. 1. Always shut down asterisk make sure you always shut down your executor service before your application exits to prevent resource leaks and unexpected behavior. 2. Prefer graceful shutdown asterisk use shutdown as your first choice. It allows running tasks to complete, providing a more stable and predictable shutdown. 3. Set a timeout asterisk use await termination, with a reasonable timeout to prevent the main thread from blocking indefinitely if tasks take too long. 4. Handle interrupted exception asterisk always catch and handle interrupted exception properly. It's a signal that the thread was interrupted, and you should take appropriate action, such as cleaning up resources or logging the interruption. If you catch interrupted exception, you should re-interrupt the thread using thread.currentThread.interrupt to propagate the interrupt up the call stack. 5. Design tasks to be interruptible asterisk if you might need to use shutdown now, design your tasks to be interruptible. Check thread.currentThread.is interrupted periodically and clean up resources if the thread has been interrupted. 6. Use shutdown now as a last resort asterisk use shutdown now only when you have no other choice and understand the potential risks to data integrity. 7. Log shutdown events asterisk log the start of the shutdown process, whether shutdown or shutdown now was called, and the result of await termination. This can help you diagnose shutdown-related issues. 8. Consider using a shutdown hook asterisk a shutdown hook is a thread that the JVM executes when it's shutting down. You can use a shutdown hook to ensure that your executor service is shut down even if the application is terminated unexpectedly. However, remember that shutdown hooks have limitations and might not always be executed. Example of a shutdown hook asterisk. In this example, the shutdown hook is registered with runtime.getRuntime.add shutdown hook. When the JVM is about to exit, either normally or due to a signal, it will execute this hook. 7. Summary. Asterisk shutdown, initiate a graceful shutdown. No new tasks are accepted, but existing tasks are allowed to complete. Asterisk await termination, timeout, unit, block the calling thread and wait for the executor to terminate, either by completing all tasks or by timing out. Returns true if terminated within the timeout, false otherwise. Handle interrupted exception. Asterisk shutdown now, attempt to stop actively running tasks and cancel queued tasks. Use with extreme caution due to the risk of data corruption and resource leaks. Design tasks to handle interruption gracefully if you might need to use shutdown now. Asterisk best practices, always shut down executors, prefer graceful shutdown, set timeouts, handle interruptions, design interruptible tasks, and use shutdown now as a last resort. By understanding these concepts and following these best practices, you can effectively manage the life cycle of your executor service instances and ensure the reliable and graceful termination of your multi-threaded applications. Remember to choose the shutdown method appropriate for your specific use case and be mindful of the potential risks involved.